Good day to all of you. Today, our news coverage will be about the Earth's endogenic processes.
We will talk about what is magma, volcanoes, earthquakes, deformation, and metamorphism.
What's up, Angelo? How are you? Hello, Angelo! Hello, viewers! As stated a while ago, we will be talking about the Earth's endogenic processes.
What? What exactly it is, Ash?
Well, from the word endogenic, it means formed, located, and occurring beneath the surface of the Earth. So the endogenic processes are geological processes that occur beneath the surface of the Earth and is associated mostly with the energy originating in the interior of the solid Earth. The ground we live on is constantly moving all the time, and the forces that move the Earth are called the endogenic processes.
Yes, Ash. In fact, the ground, rock layers, the surface of the Earth are broken, twisted, and shaken. Land is destroyed in many places and created in the other places. When the land is shaped by the endogenic forces, we call this endogenic processes.
It was stated earlier that we will be talking about magma. Angelo, can you please explain what magma is to our viewers?
Okay, so magma. You know, when the rocks are mostly here in the surface of the Earth, they are in the solid state, right?
That's right.
Yeah. However, rocks also exist in a liquid state in certain locations of the inside of the Earth. Imagine that, huh? The Earth is very hot. Those molten rocks beneath the surface of the Earth is called magma. Magma is less dense than those surrounding rocks capable of rising to the surface. Magma that emerges to the surface is called lava.
So when the magma is inside the Earth, then it is called magma. But as soon as it rises outside to the surface, it is called lava.
Precisely.
Well, magma is usually composed of abundant elements, but for most of the time it is composed of silica. One of its properties is that it has a very high temperature. For rocks, to melt them you would need 800 degrees Celsius to 1400 degrees Celsius. Magma also has the ability to flow since it is liquid, as stated earlier.
Yeah.
Viscosity is the degree of resistance to flow. Magma's viscosity depends on the silica content. It is more viscous when it is high silica content, low gas content, and low temperature. It is less viscous if it has less silica content, high gas content, and high gas temperature. What can you make of that?
I mean, when the rock or magma rather has a high silica content, it is more viscous.
Yes, it is much slower to flow.
Yeah, and when the magma has low silica content, it is easier to flow, right?
Yeah, it is more like watery,
Slippery.
yes. In regards to how magma is formed, here are the ways. First off, we have decompression melting. This is when the temperature stays the same, but the pressure is decreased. Flux melting, when the volatiles or gaseous substances are added into the solid rock. Heat transfer melting is the melting of surrounding rocks caused by very hot magma that brings in additional heat.
Here are the terms to remember in regards on how the magma is formed. Electric temperature, melting temperature of a rock, partial melting, when only certain mineral in a rock is melted. For example, iron. Iron needs to be heated for over 1000 degrees, and you take it in a shape. Fractation. When magma is separated from the rock which hasn't undergone complete melting, the magma will consist of components that melted at lower temperature, and the remaining solid rocks will contain components with higher melting temperature. Since magma is less dense than the surrounding rocks, it can move upwards rather than reason for being pressured when surrounding rocks squeeze the magma. Imagine that, squeezing in intense pressure.
A lot of squeezing pressure. Moving on.
Moving on. When the magma rises, it begins to cool. So it is just not being pressured, it's being cooled, just like my heart is very cold. Cold to her.
Go on, go on.
Some magma reach the surface and become lava, while others cool inside the surface of the earth. These cool rocks are called igneous rocks. So you're already familiar by igneous rocks. It's the rocks that came from a volcanic eruption, right?
Yes, that is
It's
correct.
it's cooled down at a very insane temperature that it does not crystallize, right?
That is. But when it does crystallize, there is a sequence of types of magma formed. This sequence is called the Bowen's reaction series. If a mafic magma crystallizes, the first mineral formed is olivine, followed by proxene, amphibole, biotite, muscovite, orthoclase, and quartz. A group of plagioclases, followed by a parallel sequence where calcium-rich plagioclases crystallizes first and sodium-rich plagioclases forms last. What do you make of that, Angelo?
I mean, when the rocks melted at a high temperature and it cools down intensively, it
is called an igneous rock.
But when that kind of magma doesn't cool in an intense temperature, it crystallizes, causing some mineral form in olivine, right?
And that is called, in describing the rocks formed, here are the terms. Ultramafic, a rock which is rich in magnesium and iron and has little silicon. Mafic, a portion of magnesium and the iron is a little less than silicon. Felsic is a rock which is rich in silica. Intermediate is when the proportion of the magnesium and the iron is approximately similar to the silicon.
Panoretic rock, formed underground and has a slow rate of cooling, able to develop coarse-grained minerals are individually visible to a naked eye. Alphanitic rocks solidifies near the surface and had a fast rate of cooling. Forms fine-grained minerals near the surface that has fast rate of cooling. Forms fine-grained minerals which are visible using hand lens or microscope.
There's a lot of terms for just rocks. Imagine that you see rocks every day. You never know their names for this rock, that rock.
Yeah, I never really considered naming a rock before.
Like, why though? Like, I mean, I get that it's really important to name things, but you know, rocks, you never realize the significance of these every day.
That's right.
Here are some of the terms in regards to the igneous rock formation. Igneous intrusions. Foreign bodies when magma solidifies underground. Dike. Magma that forms a wall-like sheet in between pre-existing rock layers. Sill. Magma that forms a tabular layer in between pre-existing rock layers.
Pluton, magma that forms a blob-like configuration and forms many configurations also. Basalt, amalgamation of many plutons.
Batholith, an amalgamation of many plutons. So in this last part, look at this. There are names for the subcategories of rock. You know, they're igneous rock, sedimentary rock, you know, that kind of, all that kinds of stuff.
Rocks.
There's names for that and names for the rocks below that. Like,
There are a lot of classifications regarding a rock, right? And it's very crucial for our survival. What the?
I just want to clarify on this last part. Pluton is like the singular unit, and batholith is a group of that single unit. A batholith is made up of many plutons.
Alright, moving on. Volcanoes. So Ash, Amy, what is a volcano?
Well, a volcano is a visible manifestation of the process of rock formation. It is a vent that serves as the conduit of lava. The funnel-shaped depression, where the materials are ejected, is called the crater. When the lava is spewed out, that is called an eruption. Now, there are different types of eruptions. However, unfortunately, I do not have them in my notes right now, so let us ask help from our dear friend Strad. Yo, Strad, can you help us out over here?
So hi guys, my name is Strad, and together with me, we have here Charles. Hi. So there are only two kinds of volcanic eruption, and that is effusive and explosive. Effusive eruption is dominated by the flow of lava and the formation of fountains and lakes. This happens when the lava has low silica content.
Explosive eruption ejects ash and larger fragments of pyroclastic materials that forms ash clouds and eventually break and covers the whole slope of the volcano. This happens when the lava has a high silica content.
I guess that's about it.
Thank you for that, Strad. That was very informative.
And in addition to having different kinds of eruptions, there are also different kinds of volcanoes. Here, we will ask help from our other friend, Kent. Kent, can you tell us more about the different types of volcanoes?
Sure, boss. Well, there are 4 different kinds of volcano according to its size. Namely, shield volcano, stratus volcano, cinder cones, and lava dome. Well, let's go to the first one, shield volcano. Shield volcanoes are large, broad volcanoes that look like shield from above, hence the name. The lava that pours out from the volcano is very thin, so it can travel great distance from the shallow slope of the volcano. Its composition is made from alternating layer of basaltic lava and cinder accumulation. Example of this volcano are located in Hawaii, like Mauna Loa and Mauna Kea. The second one is stratus volcano, or also called composite volcanoes. These volcanoes has a conduit system inside them that channels the magma from within the earth to the surface. These kinds of volcanoes can grow 1,000 meters tall. And not only that, its compositions are alternating layer of lava and pyroclastic materials. Example of these volcanoes are Mount Mayon found in Albay. The third one is cinder cones. These are the simplest types of volcanoes. They occur when the particles in a blob of lava ejected from a volcanic vent. It has a mafic composition. The last one is lava domes. Volcanoes or lava domes are created by a small masses of lava which are too viscous or thick to flow very far. Unlike shield volcanoes with low viscosity lava, the magma of the dome just pile up over and around the vent. The dome grows by the expansion of the lava within, and the mountain forms from the material spilling off of the side of the growing dome. And that's the classification of volcanoes according to its shape.
Thank you for that, Kent.
Alright, Mike. Here are some materials which are formed during a volcanic eruption. Lava flow deposits formed from an effusive eruption. Pahoho, lavas with smooth surface. Lavas with rough surface.
Obsidian, pure volcanic gas.
Pumice, volcanic gas with frothy texture, characterized by a lot of open spaces caused by gas bubbles.
Pyroclastic debris, fragmental materials of various grain size produced by a volcano.
Lapilli, pea to a marble-sized fragment of lava.
Volcanic ash, very fine particles composed of glass shards crystals, and fragments of existing rocks. Tough, lithified volcanic ash. Bombs, blobs of lava that were thrown into the air and develop a streamlined and smooth and sharp shaped fragments.
Blocks, larger non-stream chinks of lava, pyroclastic flow deposits, the aggregate of pyroclastic debris that flows on the slope of a volcano.
Ignimbrite, a pyroclastic deposit that is dominantly composed of humus.
Lahar,
A muddy-like slurry and is formed when pyroclastic debris mix with water. Moving on from that, what is an earthquake?
well, it is a sudden vibration of the earth resulting from sudden release of energy.
Here are some of the ways that an earthquake can occur.
It's triggered when the molten rocks moves up into the chamber of a volcanic before an eruption.
Explosion of a volcano.
Large landslides.
Meteorite impact.
Underground bomb test.
When the rocks break beneath the surface as a result of the tectonic forces.
In regards to the last reason, it might be actually referring to the elastic bond theory.
If a stretched rubber band is broken or cut, elastic energy from that stretch is suddenly released. Similarly, the crust of the earth can gradually store elastic energy, and that is released when an earthquake occurs.
When talking about earthquakes, these are the terms you must know. Fault, fracture on which the body of the rock slides past to another. Faulting happens when the stress acting on the fault exceeds the frictional forces on both sides of the fault. Majority of these earthquakes happen because of the movements of the fault.
Focus, also called the hypocenter. This is the energy that radiates to the surface that comes from the focus.
Earthquake epicenter. This is the area above the focus. When determining the location of the earthquake, all of these three must be considered.
Besides the location of an earthquake, we need to take a look as well as the energy released by it. The energy released from the focus travels as seismic waves. There are different kinds of ways they travel and are distinguished on where and how they move. Body waves, waves that travel within the interior of the earth. It could be a primary or a secondary wave.
The primary wave, or P wave, are body waves that causes the particle of the material to move back and forth parallel to the direction of the wave motion.
This one is a compressional wave. Now moving on, the secondary wave, referred to as the S wave or shear wave, are body waves where it causes the particles of the material to move back and forth in a perpendicular motion to the direction of the wave motion.
Surface waves, waves that travel along the Earth's surface. It could be a raylight wave or love wave.
A Rayleigh wave are surface waves that cause the ground to ripple up and down, while the love wave are surface waves that cause the ground to move back and forth in a snake-like movement. So to summarize that last part, there are 4 types of waves: the P wave, S wave, Rayleigh wave, and love wave. First, the P wave. How do you think the P wave moves?
Just move back and forth.
Move back and forth like this in this motion. Next is the S wave, which moves
Like a wave.
perpendicularly, like this, like an actual wave. Next up is the Rayleigh wave, which moves, which causes the ground to ripple up and down, like this. It's a little bit similar to the S wave, but in the sense that it ripples up and down like this. Now the last part is the love wave, which moves in a snake-like motion. Waves also vary in speed. P waves are the fastest. It's followed by the S waves and lastly the surface waves.
They're actually a tool that can help us measure the seismic waves. Sadly, we don't have any in this set, so let's call our friend Strad to demonstrate it to us.
Oh, Trust actually went out for a pee break, but you guys do know I'm not actually a seismologist.
Lucky for you, I got one in the lab which was given to me by a student for this project.
The instrument that is used to detect and record seismic waves is called a seismograph. Well, the parts of this whole instrument is called a seismograph, and this one that records is called a seismogram. It has weights, a spring, and a base. How it works is actually by, let's just remove this first. With this, as the earth is shaking, you see the spring, so if it shakes, this weight as well shakes. The record is supposed to be moving mechanically, so in the meantime, let's just use it manually. So as the earth is shaking, and the record is down, the pen moves up and down, and I guess this is not as accurate as it should be, but these are the seismic waves, and that's how it works, the seismograph. There are two kinds of seismograph. One is the one that detects vertical motion, and this is an example of that. The other detects horizontal motion. The difference is the paper is standing right here while the ball pen is protruding over there. Seismographs record the time for arrival and the amplitude of the seismic waves. The data is used by seismologists to be able to locate the location of the epicenter of the earthquake. And I guess that's all you have to know about the seismograph.
Thank you, Strad. In using a seismograph, the size of an earthquake can be measured in two ways. First is the magnitude, and second is the intensity. Magnitude is the number that indicates the relative size of energy that is released by the earthquake. Intensity, on the other hand, is the amount of damage brought about by the earthquake and is denoted by Roman numerals. The closer to the epicenter, the higher the intensity.
There are scales in order to know the intensity. The first is the Mercalli Intensity Scale, which is developed by Giuseppe Mercalli in 1902.
The second is the Philbrook's own scale, named Philbrook's Earthquake Intensity Scale, or PEIS, which was developed by Philbrook's.
An earthquake has only one magnitude, but its intensity can vary depending on your distance to the epicenter and the subsurface materials. Small earthquakes are frequent while large earthquakes are rare.
Moving on to deformation. Deformation is an alteration of the size or shape of the rocks. Deformation is caused by stress, the scientific term for force applied to a certain area.
There are three stages of rock deformation. Elastic deformation is temporary and reversed when the source of stress is removed. Ductile deformation is irreversible, resulting in a permanent change to the shape of or size of the rock that persists even when the stress stops. A fracture or rupture, also known as the brittle deformation, results in the breakage of the rock. Like deformation, fractures are irreversible.
Now there are different classifications of rocks when they are under stress. Brittle materials have a small region of ductile behavior before they fracture, but could have small or large region of elastic behavior.
Ductile materials have large regions of ductile behavior prior to the fracture, but only have a small region of elastic behavior. Also, it seems certain that Earth gets hotter as you go deeper into the crust, and soon reaches a temperature where the rock changes from solid state into a higher energy plastic fluid state. The place where this change happens is called the brittle ductile transition zone. Earthquakes only occur above this zone.
Fun fact, what we're doing right now, studying rock formations, is a branch of geology called structural geology.
To help you understand more about rock structure formed by deformation, why don't we go out? Can't!
Good.
classification of rocks according to their behavior under stress. Structures formed by deformation revolves around these two, the brittle deformation and the ductile deformation. In brittle deformation, joints are formed. Joints are natural cracks of the rock and do not slide past one another. Faults are also created in brittle deformation. The difference is that they slide past one another. We have what you call an active fault, which is a fault which slides in a recent geologic time. In faults, it has a calling for the rock beside it. The rock above the fault is what we call hanging wall, while those below of it are what we call footwall. There are different kinds of faults which vary from how the hanging wall and the footwall moves. If the hanging wall goes down to the footwall with respect, it is called dormer fault. If it goes up, reverse fault. If the reverse fault is diagonally and has an angle of 35 degrees, it is called thrusting fault. Strike slip fault is when the land slide past one another. In ductile deformation, a fault is formed. A fault is a contortion of rock layers forming wave-like curves. It has its own part, namely the hinge line or fault axis, the limbs, and the axial plane. The hinge line or fault axis is part of the fault with the greatest curvature. The second one is the limbs, part of the fault with at least curvature. And the last one is axial plane, contains fault axis of each layer. Actually, there are kinds of fault and is classified based on the orientation of its part. It can be anticline, syncline, and monocline. Anticline is when the limbs of the fault incline away from the hinge that forms an arch-like shape. The second one is syncline, when the limbs are inclined toward the hinge that form a true-like shape. And the last one is monocline, bent in generally flat-lying rock layer. In regards to how mountains are made, well, this happens when two plates move toward each other. As they push, the rock moves upward, and that's what a mountain is. Also, when this happens, not only one mountain can be made, but can make a mountain ranges. And that's all, folks.
Thank you, Kent. Now let us move on to our last topic.
It is metamorphism. It is the process that occurs when the rock changes its form into a new one without undergoing melting or disintegration. There are different types of metamorphism.
First up, there is contact metamorphism. When metamorphism happens because of a high temperature and the presence of hydrothermal fluid. Burial metamorphism. This is when sediments pile up and become thicker. The pressure increases due to the weight, and the temperature also increases. This occurs when this occurs, metamorphism happens. Cataclastic or dynamic metamorphism is when the rocks crystallize in the fault zones. Regional metamorphism. This is when the protolith or original rock is buried, giving it more pressure and higher temperature. When it is subjected into different stress, this could result in a fractional metamorphism or dynamic metamorphism.
Hydrothermal metamorphism. When the hydrothermal fluid reacts with certain rocks and minerals, like existing basalt, it produces a new chloride mineral. Shock metamorphism. When extraterrestrial objects such as meteorite hit the surface of the earth, it causes the rock to undergo metamorphism. This is because of the vast amount of kinetic energy in the meteorite has. And with the energy, the heat will quickly vaporize the rock. It causes it to change its chemical structure.
There are also certain processes that make up metamorphism. Shred, could you help us out here, please, and explain what these different processes are?
Well, there are 5 processes that make up metamorphism. Number 1, recrystallization. This is the change in the size and shape of a mineral while still having the same identity. Number 2, phase change. This is the change in the crystal structure while still having the same components.
Neocrystallization is the growth of the new minerals that differ those who are in the polyp. Okay, the next one is pressure solution. It is the dissolution of materials when a rock is dominantly squeezed in one direction with the presence of water. The last one is plastic deformation. It is when a mineral is elongated or flattened without changing its composition.
Yes.
This is because of the plastic behavior.
Well, in regards to what are the causes for metamorphism, there are only 3 which I can think of, and that is pressure, temperature, and the presence of a hydrothermal fluid. And that's it.
Thank you for that, Fred. Now this concludes the special broadcast. Thank you for listening. We do certainly hope that you learned something from this.
This is Clover News signing off.
This has been a special segment of Clover News reported by people with special needs. Signing off.
Yo! Guys, bilis niyo magbihis.
O nga, ganun lang napakabilis. Napansin nyo, napaka-good job natin, di ba? Talagang bigay or ano talaga procrastinator, kaso lang talagang binigyan ko effort.
Good job, guys.
We learned a lot.
Did learn a lot.
Yes.
And you know, guys, with all that learnings, can you guys share to our viewers out there, the things you can reflect upon those things we just shared to them a little while ago? Can you please start?
No, I'll start. I mean, first off, magma is hot.
Yes. Yeah. As long as it goes up, it goes. So like in our life, whenever we goes up and ask guidance to God, find situations in hot, it cools. So we are guided. Yes. And we have peace of mind if we are in God.
Inner
We are guided. So the lesson there is you always have to go up and ask guidance to God.
Yes.
And assistance for us to be guided on how to solve our problems.
Libre naman.
Well, how about you, Ash? Can you share to our viewers about what you just reflected about what we have learned?
Well, how about know you?
Go back to
So we just talked about a little while about metamorphism and how it changes the rock. For the rock to be able to change, it has to go through very high pressure, high temperature, and even have to go into contact with hydrothermal fluid. So we can say that the rock, for it to change, it has to go through, you can say like hardships. Same with us. For us to be able to be disciplined, to grow, we need these hardships and trials. Whenever you are in hardships and trials, don't get mad at these things. Instead, take it as an opportunity for you to be able to grow more and to develop, I guess.
As for me, I know all of you knows deformation.
Yes,
right?
we know deformation.
Especially this deformation. Yes. Did you know that as a rock deform, it's deformed? Yes. Really? Yes. Man, yes, man. It's deformed because of the pressure, the stress that release into it. So it loses its shape, right? Yes, it loses its shape and it's changed.
It's not yummy.
Yes, but sometimes in our lives, we need to change. Change in everything we do. Pagbabago sa lahat ng ating ginagawa. At, syempre, kailangan natin magbago para sa ikabubuti natin.
Yes.
We need to change for the better.
Yes, indeed.
How about you, Ash? You cannot use that card anymore.
Man, alright. I really like the part when I was reporting about the earthquakes. It surprised me when I learned that there's an earthquake happening every day. could be one happening right now. I mean, it may not be here. It could be here, but we just don't feel it. We might not feel it, but there's an earthquake happening. But the thing I like about that is every day we receive blessings from God, and these blessings, some of them or most of them, we don't notice. We don't feel like waking up in the morning, waking up after a long rest. That's a blessing. That's some people sadly don't get to wake up after they sleep. The food that we eat, the meals every day, and people sometimes take that for granted. They don't realize that a lot of people are in very much need of food. So that's really the thing I like about. There are blessings that we don't notice, just as there are earthquakes that we also don't feel every day.
Hindi siya. Napansin ko sa earthquake, yung mga tao talagang seryoso dyan. Pag nangyayari na, parang kukunin na yung kaluluwa.
It's dangerous. Yes.
So, sobrang seryoso nila, meron pa nga silang duck overload, di ba? Prepare, dark. Preparation, napaka-seryoso ng proseso na pagdadaanan para lang sa protection ng may earthquake. Pero hindi nila alam kung bakit nagkakaroon ng earthquake. Yung pinaka-rason, ang alam lang nila na mamamatay sila pag di nila na-duck overload. Pero ang talagang rason na yun ay paparating na ang second coming ni Jesus Christ. Di ba?
Amen!
Yes!
You know how there's an aftershock? You know that the second earthquake,
Laging sprinkles. Daw, pag mga circumstances like earthquake, the more earthquake, the more we need to prepare because the second coming is getting near and God will save us from all us.
Yes, Jim. I like that, how we prepare. Dapat di lang sa physically ang prepare natin, kundi pati rin spiritually.
Mentally. Visually.
Yes. So,
ngayon nga, sa mga nanonood dito, we do very much hope you learned something and you enjoyed watching us also.
at siguraduhin nyo lang makakapasa kayo sa exam.
Tama. Good luck guys. Good luck.
So, I guess this has been Clover.